All right, section 7.2, similar polygons. We're going to start with the definition of similar. Definition of similar polygons. The symbol for similar is just a squiggle, just a tilde. Now that means different things in logic. When we did the contrapositive statements and all that, that meant not. Okay. Here it just means they are similar. Okay. That happens all the time, though, right? I mean, what does this mean? Number, hashtag, pounds. Okay. So in different systems, it means different things. So this means similar. Definition of similar polygons. Two polygons are similar if and only if the corresponding angles are congruent and corresponding sides have the same ratio. This is going to be very similar to congruent triangles, okay, where the corresponding sides were congruent and the corresponding angles were congruent. Here, though, they just happen to have the same ratio. So, let's do an example. And we'll call the top one, we're going to call the top one UG. And we'll call the bottom one So, are UG and Alex similar? Well, let's answer the question. Are the corresponding angles congruent? Let's see here. Angle Y, what does that correspond to? A, those are congruent. U corresponds to L, are those congruent? They are going to be congruent, because this is a parallelogram, right? So how much is angle U? 80. This is also 80, right? So it's got to be 100, that's got to be 80. So, are the corresponding angles congruent? Yes, they are, right? Angle U is congruent, sorry, angle Y is congruent to angle A. Angle U is congruent to angle L. Angle A is congruent to angle E. Angle I is congruent to angle X. Yes, the corresponding angles are congruent. Are the corresponding sides, do they have the same ratio? Well, let's match up the corresponding sides. YU, AL. I like to put the small one on top, but you don't have to, okay? AL over YU, is that going to equal UJ over LE. Oh, sorry, I suck. LE over UJ. Will that equal EX over JI? And will that equal AX over YI? Well, if we plug the numbers in, it's pretty easy to see, right? This is 8. This is 2. So we're going to have 2 over 8. Is that equal to LE over UJ? Well, if it's a parallelogram, this has got to be 4. That's got to be 8. It's got to be 1. That's got to be 2. Is that equal to 1 over 4? Yes. Is that equal to 2 over 8? Yes. Is that equal to 1 over 4? Yes. So are these two similar? Yes, they are. And so UG is similar to Alex. This right here is called a similarity statement. That's a similarity statement. Now, scale factor. The scale factor is you just pick up two corresponding sides, make them a ratio. Scale factor, pick two sides that correspond, like 2 and 8. 2 to 8. Simplify it so they're whole numbers. So this would actually become 1 to 4. Now what if this were 0.5 to 4? Can we have 0.5 to 4? No, so you have to double it. Not a huge issue, and I say that when in real life it's normally like, hey, we're okay with that. Remember how your middle school teacher said you can't have improper fractions? You remember when your middle school teacher told you that? Were they telling you the truth? No, of course you get improper fractions. We do it all the time in algebra. So, really, they say, you know, make it nice and neat, whole numbers. In real life, whatever. So that's finding scale factor. If you know two things are similar, you can set up proportions. I'll do an example here. Example. A, B, C is similar to X, Y, Z. Triangle A, B, C is similar to triangle X, Y, Z. Two things to do here. Find the scale factor. And also find X and